All right, guys. I want to go through some of the study island topic that you are working on for today. It's called Solutions to Linear Equations. Just a heads up, you do have a classwork grade on this topic tomorrow. So make sure that you are asking all the questions that you have for today, and so you're good to go tomorrow, okay? So right now, I am going to try to zoom in a little bit, but still have those tools. Maybe not. All right, so we're going to look at question number 1 here. All right, so it says, which of the following best describes the solution to the equation below? All right, so I'm going to, kind of give you some insight onto how to think about these kind of critically. So if I'm at this point in my equation where I don't have any more distributive property and I look on my left-hand side and my right-hand side of my equal sign, and I'm looking here and I can't combine like terms, same here, I can't combine like terms. Well, now I can look at each term here. So if I have 16x and I have 8x, okay, those are very different numbers, right? 16 and 8. And then I have a plus 12 and a plus 35. So I have different x values and different constants. So in this case, I already know, because I can look for patterns to see if it's going to be one solution, no solution, or infinitely many solutions. So in this case, I already know that it's going to have one solution, but if you're not sure, when in doubt, you can always just go ahead and solve. So I'm going to erase some stuff real quick. And we're going to go ahead and just solve. So if I have two x terms, one on each side, so I have to use the inverse operation. So I'm going to look at this 8x here, and I know that it's a positive 8x, so I'm going to subtract 8x, subtract 8x. All right, I'm going to kind of run into these problems, but you'll be all right. So over here I have, 16x minus 8x is 8x. Still bring down that plus 12, and then equals, and I have 35. All right, next step. Remember, I'm going in reverse order of PEMDAS, so I still have adding and subtracting to deal with, so I have to deal with this plus 12. Inverse operations tells me to subtract 12 from both sides. I have 8x equals 35 minus 12 is 23. At this point, okay, I'm done with adding and subtracting, but I'm looking at my x right here, and I know that this is multiplication, so I'm going to divide using that inverse operation. Okay, I have 23 divided by 8. All right, I'm going to actually convert that into a mixed number. Just judging by my options right now, I think I know what it is, but I'm going to make sure. So 23 divided by 8. All right, 8 goes into 23 how many times without going over? Looks like 2 times. So, that's not a 6. There you go. Subtract 16. Well, that's going to give me 7. 8 goes into, you know what? I have a fraction over here, so I'm going to use this as a fraction. So with this remainder, without going into decimals, my remainder becomes the numerator of my fraction, and my divisor becomes my denominator. So that would be a total of 2 wholes and 7/8. So I know this has exactly one solution, but I already knew that. But now I confirmed that with the actual solution it gave me. All right, we're going to look at the next one since it has a fraction. I know sometimes that freaks you guys out, but guys, you know how to work with fractions. You will be totally fine. All right, good enough. Moving on to number 2. Oh my goodness. All right, number 2. So this one tells me what best describes the solution to the equation. All right, at this point, I can't critically kind of analyze it yet because I haven't done the distributive property. Once I do that, I can kind of look for those patterns to determine if it's one, no, or infinitely many solutions. So I'm going to distribute 1/2 times 6. Remember, I can kind of go off to the side and say 1/2 times 6 over 1. Well, it gives me 6 over 2, which reduces to 3. So that gives me 3x. Again, I'm kind of writing over things. And then 1/2 times 9, which is going to give me, or sorry, I should say a negative 9. So 1/2 times a negative 9, I can put that over 1, gives me negative 9 over 2. Or I can divide that out and say negative or minus 4.5. And then I'm going to bring down everything else. So 3x plus 7. Okay, so this one is a good example because I can look for some patterns. And here's what I'm looking at when I look at patterns. So again, I can only look for the patterns whenever I don't have any distributive property. So that's why I had to do that first. And I don't have any terms to combine on the left-hand side or the right-hand side. So now that I did basically step 1 and step 2 of our process, I can kind of think to myself, okay, is this going to have one solution, infinitely many, or no? So again, I'm looking at my x values. So I have 3x. Ooh, and I have another 3x. Okay, so no matter what number I put in for x, these values are going to be the same no matter what because x is the same. And if I multiply that same number by 3, well, it doesn't matter which side it's on. It's still going to be the same number. So if x was 1, well, 1 times 3 is going to give me just 3. Same thing here. If I use 1 times 3, it's still going to be 3. So these are going to be the same number. That's why I made them the same color and boxed them in. So now I got to think about this a little bit more. Now my constants, I have a minus 4.5 and a plus 7. Ooh, okay. So let me think about this. Those are two very different numbers. Probably should have made them different colors, to be honest with you. Let's do that. So they're different numbers, they're different colors. So 3x and 3x are the same. So if I take the same number and subtract 4.5 from it, is it going to be equal to that same number, but adding 7 to it instead? No, that doesn't really make sense, right? So if I take the same exact number and subtract 4.5 one time and add 7 the next time, they're not going to be equal to each other. Okay, so it's never going to be equal to each other if I have this 3x, which I know is the same, and that 3x, which is the same, and have two different numbers here. Okay, so I know that this is going to be no solution. All right, I get it. Maybe you're not comfortable recognizing those patterns yet. But if I'm not sure yet, it's all right. I can go ahead and solve it out. So I'm just going to put back what we did after the distributive property. All right, I'm going to go ahead and start solving. And I got my x terms, so I'm going to go ahead and deal with those first. So remember, I'm doing reverse order of PEMDAS at this point. So I know that these are positive 3x's. I'm going to subtract 3x from both sides using that inverse operation. And now I have just negative 4.5 because those canceled on the left-hand side, and the 3x's canceled on this side as well. So they both canceled. And then I have a positive 7 on the right-hand side. Now you have to ask yourself, is negative 4.5 ever going to be equal to a positive 7? No, it's not going to be equal. So I know that that's no solution, even if I go to solve it. All right. Let's move on to a word problem. All right. These word problems are really no big deal. Don't let them freak you out. You got to take them piece by piece, though. If you're trying to do too much at one time, it's going to be really, really confusing. Okay, so I recommend reading the question first before you start writing things down, and then going back to read it again to start writing things down. And I'll show you what I mean. So Aaron and Dan went shopping at their local store. Aaron bought shirts that cost $12 each and spent $18 on accessories. All right, Dan bought the same number of shirts as Aaron for $16 each and spent $10 on accessories. If Aaron and Dan were billed the same amount, okay, these sames are really important, same amount by the store, how many shirts did each of them buy? Okay, now, if they were billed the same amount, okay, if something's the same, that means it's going to be equal to, okay? So if it's equal to, I'm going to start kind of writing my equation with an equal sign. So if Dan and Aaron were charged the same, that means I can put Aaron on one side of my equal sign and Dan on one side of my equal sign. So now I have to determine how to represent what they were charged. So let's go back up to what we kind of highlighted earlier, or underlined because the highlight option is not available. So Erin bought shirts that cost $12 each. Okay, do we know how many shirts she bought? No, that's actually what it's asking. So if I don't know how many shirts she bought, what do you think we're going to do to represent that? Yeah, we're going to use a variable. Okay, so if we don't know something, we're going to say it's a variable. So I'm going to say x equals number of shirts. Of shirts. All right, so $12 on each shirt. Okay, well, that's saying $12 times the number of shirts. So that is going to be represented by 12x. Okay, but then she also spent $18 on accessories. Okay, do we know how many accessories? No, but it's also not saying $18 on each accessory. So it's just saying $18 total on accessories. So that's just a flat $18. And we're adding that because we want to know the total price that she's paying. Okay, so we have $12 per shirt plus a flat $18 for whatever accessory she bought. Okay, now we got to go to Dan. Same kind of thing. Dan bought the same number of shirts, but we still don't know that number yet. So that's X still for $16 each. Okay, so his were a little bit more expensive. So that's 16X. Okay, so 16 times the number of shirts. But then he spent $10 on accessories. Okay, so again, we want to know the total for Dan. So we're adding the $10. Again, it didn't say each accessory. It just said $10 on accessories. So that's a total amount for all of the accessories he bought. Okay, so now we have an equation to solve. All right, so let's get down to it. We have two x values, and we want to get them on the same side. But before I do that, let's analyze this for a second. So we've got x value of 12x and 16x, so those are different, okay? And then we have 18 and 10. So again, no distributed property, no combining like terms because that's already been done. So at this point, I know that there's going to be one solution. All right, now we can actually get down to it. Let's go ahead, and I want my x terms to be together, so I need to use inverse operations because they're on opposite sides of my equal sign here. Oh, it didn't switch me over to the pen. All right, so I'm going to subtract 12x. That's what I decided to do first. Keep in mind, guys, your first step here could be multiple different things. It doesn't have to be minus 12x. That's just what I'm choosing to do because I know I have to deal with adding and subtracting, and that's what I'm choosing to work with first. So I'm subtracting 12x. Got to keep it balanced. And I'm left with, I know that's going to cancel out, leaving me with a positive 18 equals, well, 16 minus 12 is going to leave me with 4, and I still have that x. And then I still have plus 10. Again, still working with reverse order PEMDAS. I still have adding and subtracting. So now I'm going to subtract 10. Since I don't have any more x values to kind of be concerned about, I only have 1 now, and that's what my goal was, so I can subtract 10 from both sides. Keep things balanced. 18 minus 10 gives me 8. Left with 4x. I can divide by 4, use that inverse operation. So x, kind of running out of room. So x is equal to, well, 8 divided by 4 is 2. So I know that x represented this number of shirts up here. So I know that Dan and Aaron each bought 2 shirts. So once you have that equation written out, all you're doing is solving. And I know that you guys are good at that by now. All right, we're going to look at this next one. There's so much junk everywhere. All right, we'll scroll up, and hopefully it'll scroll up with it. Oh my goodness, let's go. Okay, number 4. It says complete the equation below to create an equation with exactly one real solution. Okay, So we've seen this before, and our x terms had to be the same or different numbers for that coefficient. So like our 3x before and our 3x, like 2 problems up, is that going to create a 1 solution or no solution or infinitely many? So when I think about that, I'm thinking about those patterns. So keep in mind, I can't look at those patterns until I've taken care of the distributive property and combined like terms. So I'm going to split this kind of into the left-hand side and the right-hand side and think about that. So I need to take care of this left-hand side and go ahead and distribute first. So 3 times 3x gives me 9x. Normally I'd write it right underneath. It's just kind of small. So, and then 3 times a positive 5 gives me a positive 15. And I still have that minus 4x on this side. So I don't have any more distributive property, but I can combine like terms. I have a 9x and a minus 4x, which is going to give me a total of 5x plus 15. And I'm going to bring this over and just kind of rewrite what they gave us here. So if I want one real solution, I got to think about this. It gave me an option of 5, can't be determined, or negative 5. So I'm just going to substitute those in and we're going to think about them. So I'm going to start with this 5. So if I start with 5, all right, let's think about this. Well, now I have exactly the same thing right here, 5x and 5x. So if I took that number and I added 15 to a number and took that same number and subtracted 10, are they ever going to be equal? No, because I can't add 15 one time and subtract 10 the next time, and then they be the same exact number. That's not going to work. So for example, if I used 2 for x, again, it doesn't really matter what x is, but if I use 2 for x, that would be 10, because 5 times 2 gives me 10, plus 15. Well, then 5 times 2 again over here is going to be 10, minus 10. Well, that's never going to be equal. One side's going to be 25, and one's going to be 0. Doesn't matter what x is, it's never going to work. So does that give me one real solution? No, this gives me a no solution. So 5 isn't going to work, okay? So I know that A can be eliminated. Okay, well, let's go to negative 5 and see if it can be determined, or we have to select B. All right, so negative 5, let's think about it. So one real solution. Well, okay, these aren't the same numbers anymore. So I have negative 5x and I have a positive 5x. So I can go ahead and solve and actually see what works. So again, I have x values. I don't have distributive property, don't have to combine like terms. I'm going to go ahead and start solving. So I'm going to add 5x. Add 5x. Remember, I want to get those x terms on one side of the equal sign. And I have a 10x plus 15 equals negative 10 left on the right-hand side. Now I can subtract 15, and that's going to leave me with a 10x over here equals, well, negative 10 minus 15. If I think about dojo, if I'm at a negative 10 and I am losing 15 more, I'm going to be at a negative 25, which is pretty rough if you ask me. And then I can divide by 10 because I know that's the inverse of multiplying. So x would be equal to a negative 2.5. All right, well, that's still one solution. Doesn't matter if it's negative, doesn't matter if it's a decimal or a fraction. They gave me x is equal to one number, okay? It doesn't matter what that number is. So it gave me one real solution. So I know that negative 5 is going to be the correct answer here. All right, we're going to do another word problem, and then we'll kind of wrap it up. Keep in mind, guys, if you have more questions, you know to email me. You have my phone number. I even posted it like at the top where that picture is on Classroom. My phone number and my email address are up there now. So feel free to do whatever you need to do. All right. Let me get that off of there. Good enough. We'll go ahead and look at number 5. All right, number 5, Michael hires a cab that charges a fare. Again, read this first and then start figuring out how to do this, okay? So read everything first. So Michael hires a cab, it charges a fare. So that's just a charge, right, of 50 cents per mile plus an initial charge. So remember, initial just means a starting out fee. It's like a flat fee. So initial charge of $2. Jason hires a cab that charges a fare of 50 cents per mile plus an initial charge, again, just a flat fee of $3.50. At how many miles will the fares be paid by Michael and Jason become equal? Ooh, okay. So last time with this word problem, we had the word same. Okay, well, same really means equal. So I'm going to write my equal sign. And it's telling me at how many miles will the fares be paid by Michael and Jason become equal. So I know that I'm going to have good old Mikey over here and Jason over here. Okay, because I want their fares to be equal. So now I have to think about them kind of separately, all right? So I've got, let's look at Mike first. Michael hires that cab at a fare of 50 cents per mile. Well, do we know how many miles? No, it's asking us how many miles. So X is our unknown, and that represents the number of miles. All right, so 50 cents per mile. So I'm going to say 0.50x. So that's 50 cents times the number of miles. Plus, okay, I'm going to take that seriously, plus an initial charge of $2. Well, he's not paying that $2 over and over. He's not multiplying by anything, so that's just a flat $2. All right, now Jason, 50 cents per mile. So, all right, we don't know how many miles, but we know it's 50 cents times the number of miles, so X. Plus, okay, an initial charge of $3.50. So he's only paying that $3.50 one time. So we're only going to put it here one time. It's not being multiplied by anything. Okay. Well, now let's think about this. If I'm looking for those patterns, I'm going to think, all right, my X terms are both 50 cents times X. 50 cents times X. So if I can think of that as like 0.5, right? Like a half, because like 50 cents is half of a dollar. So a half times a number and a half times a number. That's going to give me the exact same number, right? So these two are exactly the same. If I take this number and I add 2 to it one time, I'm going to get a certain number. And then if I add 350 to it, I'm going to get a different number, right? So if I add 2 to it, okay, that's going to be less than when I add 350 to it. So is it ever going to be truly equal? No, it's not going to be. So at this point, I know that they're never going to be equal. But if you didn't notice that pattern, totally fine. Let's look and see what else we've got. I can go ahead and solve, right? So I got 2 different X terms. I'm going to subtract that 50 cents X from both sides because I am, I don't have the first 2 steps to distribute or combine the terms. So when I do that, they both end up canceling. So I have a positive 2 equals, canceled out here as well, a 350. Well, is 2 actually equal to 350? No, it's not. So I know that this is a no solution, so those will never be equal. All right. So you keep working on this, screenshot me problems, send them to me if you need some help, and I will gladly help you. Remember, your classwork grade is on this topic. So these are obviously very similar questions of what your grade's going to be tomorrow. Good luck, guys.